All right, let's look at 31. 31, again, you see some fractions. I think we're pretty tired in looking at fractions. Not my personal favorite. So what do you do when you see two fractions like this? Okay. Do you do cross multiply? Now, we will not advise to do cross multiplication because you have an inequality sign. As you know, if you multiply by a negative number, you have to flip the sign. Now, the problem is that if you multiply the term x minus 3 and x plus 1, well, which one is, like, do you know if it's positive or negative? Well, we're not sure. And that would really cast a lot of doubt and complications on this situation. So what we can do is to say, well, let's go ahead and make one side equal to 0 by subtracting one fraction to the other side, subtracting 2 over x plus 1 to the other side. Well, what's the benefit of doing this? What's the benefit of doing this? Well, the benefit is that now we can have a single fraction by doing common denominator, which is something that we have done for the previous couple questions. And you just need to make sure that, do you really remember? Do you still remember how to do common denominator? All right, so you have 1 times x plus 1 minus 2 times x minus 3. Okay, so that's how you do common denominator. If you have trouble doing common denominator, I give you a suggestion. Just go ahead, try this. Okay, just go ahead and try this out. Ask yourself, what would you do when you have this fractions subtracting each other? And I hope that you will give yourself this kind of instruction that, well, you don't have the 4, you multiply 4 over 4. You don't have the 3 for the second fraction, you multiply by 3 over 3. So that's what we do. That's what we do. So here we are multiplying essentially x plus 1 over x plus 1. And then here, x minus 3 over x minus 3. Okay, that's how you do common denominator. And let's go ahead and simplify the fraction a little bit, simplify the numerator specifically. So we've got the simplified or the denominator in factored form. So you have x plus 1 minus 2x plus 6. Okay, plus 6. Almost wrote down the 3, but it's plus 6 because you have to multiply the 3 by the 2. And let's see right here. So you have minus x plus 7 in the numerator. Okay. And then, well, I guess let's go ahead and do the sign chart in this case. And then we can also do the graph at the end of it. So we have negative x plus 7 and then x plus 1. I guess I should make the order a little bit more user-friendly. So let's do this. Okay. Now, I actually might want to do this instead. Instead of saying negative x plus 7, let me just do 7 minus x. That would look a lot better. And then I would have negative infinity to infinity. Okay. So this f of x overall. Do I have any vertical asymptote? Let me say yes, we do. We have a vertical asymptote at negative, I'm sorry, not negative 3, positive 3. Positive 3, okay. And also at negative 1. Okay. And then we have we have an x-intercept at x equals to 7, actually. Ooh. If x is equal to 7, I want to let me erase something right here. erase something right here so that I can spare a little bit more room for my x-intercept of 7. Okay, so that would be the arrangement of my sign chart. So let's go ahead, fill in some signs. Well, for the first factor, it will be positive as long as x is less than 7. But if x is greater than 7, that will be negative. For the second factor, x minus 3, well, it will remain positive if x is greater than 3, but it becomes negative if x is less than 3. And then you have x plus 1, the factor x plus 1. If it is less than -1, then it will be negative. Otherwise, it will be positive. So the overall sign would be positive for the first column because you have negative times negative. And then you have a negative, and you have a positive, and you have a negative right here. And we want the overall rational equation to be greater than or equal to 0. So that means we want this portion of the graph and this portion of the graph. Our overall solution set, it's going to be negative infinity to -1 union 3 to 7, and make sure you use a bracket. Use a bracket for 7 because we do include the 0 for the y value. So when x is 7, the y is equal to 0. Okay. If you do the graph method, what kind of graph would you see here? You will have a horizontal asymptote of 0 because the denominator's power is greater. So that means you have a bigger denominator as x goes to infinity. There's an x-intercept at 7. You have 2 vertical asymptotes. Okay. And this is 7. And the intercepts, what's the y-intercept? The y-intercept would be, it would be what? Negative 7/3. So somewhere right there. Okay. We have only one x-intercept. Okay. So based on the sign chart, we can conclude that's going to look like this. And it's going to look like this. Okay. So that's what we have for the function. Okay. So sign chart and the graph method. Okay. So when you do the graph method, just make sure one thing. The equation tells you that you have only one x-intercept, which is at 7, 0. Do not create more x-intercepts. Okay, because some students they may do something like this. They may be like, oh, there's a y-intercept right here, so they just feel like doing this. Well, we do not have any additional x-intercept or yeah, x-intercepts. So it has to stay like this. Okay, there's no way to pass through the x-axis again. Okay, it's just not allowed. So so that's our solution set.